Good day everyone. I'm going to discuss about our topic, which is principles of thyristor control, DC converter for speed and torque control of DC motors. The DC motor is a main part of equipment in many industrial applications requiring a variable speed and load characteristic due to its easy controllability. There are different types of control loops: current controller and speed controller. These DC motors are widely used in the industries because of its versatile characteristics, which have contributed in the extensive use of DC motor in the industry. The DC motor can control by various methods, which are as field control, armature voltage control, armature resistance control. The thyristor-based DC drive with the analog and digital feedback control schemes are used for the speed control technique of DC motor. This drive also providing the function like start, stop, forward braking, reverse braking, increased and decreased speed of motor. A thyristor is a solid-state semiconductor device with four of alternating N and P-type material. It acts as a bistable switch, conducting when gate receives a current trigger and continuing to conduct while the voltage across the device not received. A 3-lead thyristor is designed to control the large current of its two leads by combining that current with the smaller current of its other two lead, known as a control lead. Some sources define silicon controlled rectifier and thyristor as synonymous. Other sources define thyristor is a large set of device with at least 4 layers of alternating N and P types material. The first thyristor device was released commercially in 1956 because thyristors can control a relatively large amount of power and voltage with a small device. They find a wide application in control of electric power, ranging from light dimmers and electric motor speed control to high voltage direct current per transmission. A thyristor unsuitable as an analog amplifier, but useful as a switch. A silicon controlled rectifier or semiconductor controlled rectifier is a 4-layer solid-state current controlling device. Mathematical modeling of DC motor. The dynamic and steady-state model of separately excited DC motor is needed to analyze the torque speed characteristics. The schematic representation of the model of a separately excited DC motor is shown in the figure below, in which AA is the terminal voltage applied to the motor. RA and LE are the resistance and inductance of armature circuit respectively. RF and LF are the resistance and the inductance of the field circuit respectively. EB is generated back EMF and TM is the electromagnetic torque developed by the motor. There are 3 methods of speed controls are as following: armature voltage control, next armature resistance control, last the flux control. The thyristor-based techniques of DC motor speed control. Single-phase half-wave converter feeding a DC motor offers only one quadrant drive. Such type of drives are used up to about 0.5 kilowatts DC motor. A half-wave converter in the field circuit will increase the magnetic losses of the motor due to high ripple content on the field excitation current. So, an ideal DC source is preferred over half-wave converter for field circuit. These converters also offer only one quadrant drive and is used up to 15 kilowatt DC drives. These are the 2-quadrant conversion. The positive VD implies rectification, then the negative VD implies inverter mode. That's the figure 6-1, the line frequency controlled converter. This is also the thyristor gate triggering. Delay angle is the angle alpha is equals to 180 degrees times the V control over the VST. This is the figure 6-3, the gate trigger control circuit. Thyristor converter waveforms. Assuming 0 AC side inductance, so that's the 0 AC side conductance. At omega t, 0 thyristors 1 and 2 are triggered. At omega t, Pi thyristors 3 and 4 are triggered. Practical thyristor converter. Waveform for angle of 45 degrees. Average value of VD. Thus the figure 6-11, a practical thyristor converter for A and the B is the waveform. Speed control of DC motor. The DC motor is of considerable industrial importance. The principal advantage of a DC motor is that its speed can be changed over a wide range by a variety of simple methods. Such a fine speed control is generally not possible with AC motors. In fact, fine speed control is one of the reasons for the strong competitive position of DC motors in the modern industrial applications. The torque control of DC motors. Whenever armature carries current in presence of flux, conductor experiences force which give rise to the electromagnetic torque. Electromagnetic torque will be developed both in motor and generator mode of operation. It may be noted that the direction of conductor currents reverses as we move from one pole to other. This ensures an unidirectional torque to be produced.